This is the most likely candidate: the red planet, Mars. To a visitor from Earth, a tour of Mars might be very reminiscent of places back home. Places like Southern California's Mojave Desert, geo and astrobiologist Ken Nielsen finds this desert area so much like Mars, he comes here to try to better understand conditions on the red planet.
You travel around here in the dune buggy and you see features that look just like the dune features on Mars. If you go further and look in the background and see all of these red hills full of iron oxides that we see on Mars, Mars is filled with iron, and its oxidized iron, basically rust, turns into dust particles. And in addition to the beautiful dunes, you have this red atmosphere, sometimes red all over the surface of the planet. Huge dust storms. They don't call it the red planet for nothing.
But while much of the Martian terrain is similar to Earth, some geological features dwarf any of their kind on our home planet. A mountain named Olympus Mons, Latin for Mount Olympus, is the tallest known peak in the solar system. It's a now dormant volcano that rises 15 miles above the Martian surface.
If you draw a picture of Olympus Mons and put it next to Mount Everest and the big island of Hawaii, even taken all the way down to the base of the ocean, they look like molehills compared with Olympus Mons on Mars. That mountain is so large, you could be on its slopes and you would not know that you're on the slope of a volcano because the base is so huge before you get to its summit.
Yet, as awe-inspiring as the Martian surface appears, it is a brutal, inhospitable zone for human beings.
6 green board, 5, 4, 3, 2, 1, engine start, and liftoff of the Delta II rocket carrying the Spirit from Earth to planet Mars.
It's cold, it's dry, it's desolate. There are dust storms that can darken the skies for weeks or even months at a time. It goes down to 100 degrees below zero at night, every night.
Compounding these cruel conditions is an atmosphere with no oxygen. Martian air and even occasional cloud formations are made up almost entirely of carbon dioxide.
So it's not a nice place. You wouldn't enjoy it if you went there.
Mars is small relative to the Earth, only about half the size of our planet. And its distance from us is never less than 34 million miles. It appears as nothing more than a tiny red orb in our night sky. Even so, Mars has captivated humankind for centuries. The planet takes its name from the Roman god of war. The Romans associated this distant world with hostility and unrest because of its blood-like color and because of its distinctive movement in the sky.
Mars wanders. It doesn't do what the stars do.
The red planet occasionally appears to be moving backward across the sky, a behavior that confounded observers for centuries. But in 1514, close study of this planetary movement led Polish astronomer Nicholas Copernicus to a revolutionary understanding of the solar system.
For much of recorded history, people thought that Earth was at the center of the universe. So along comes Copernicus, and he says, no, maybe the Earth isn't at the center of the universe. Maybe the explanation for all this is that things are going around the sun. And if all the planets are going around the sun, then we can explain why, as Earth passes Mars in the orbit, Mars begins to wander in our sky. It looks like it's going this way, and then it starts to go this way.
By the time of Copernicus's observations, Mars and the Earth had been passing each other in their respective orbits for some 4.5 billion years. Time enough for the two planets to have evolved into very different worlds. One warm, wet, and oxygen-rich. The other cold, dry, and oxygen-depleted. Yet it's now believed that the differences weren't always so stark. Scientists today think that Mars was once warm enough for large amounts of liquid water to flow across its surface.
When we look at Mars today in our best satellite images, they tell us the same message we heard with the first missions to Mars, and that is that there's no liquid water on the planet today. But there's virtually incontrovertible evidence that there was water there in the past. Everybody knows that when water flows through any sort of dirt, there are characteristic structures that are a function of that water running through. And when we look at the pictures of Mars, the satellite images, we see very similar structures leading us to the absolute conclusion that Mars was once far warmer and wetter than it is now.
Mars, of course, is a harsh desert today. So what could have happened? What cosmic processes could have brought about such a dramatic transformation of the fourth planet from the Sun? The story begins with the origin of the solar system. Somewhere in the range of 4.5 billion years ago, our solar system sprang from a supernova, a stellar explosion emitting a swirling mass of molecular particles and gases. This swirling mass, or nebula, began to cool, and as it did, it condensed and separated into rings of particles. These particles began to accrete, or gradually clump together to form planets. The accretion process creates heat, and heavier particles sink to the center of the accumulating mass. So Mars eventually formed a molten iron core. This churning molten core generated a powerful magnetic field. The field projected outward, surrounding Mars like a protective shield, blocking harmful emissions from the Sun.
You have this constant pressure from the Sun, which we call the solar wind. The solar wind is made of protons, electrons, cosmic rays, all of these kinds of charged particles that could ionize the atmosphere, as we call sputter it away.
But eventually, Mars lost its protective shield and most of its atmosphere. The moment the accretion process ended, the planet began to cool.
The iron core was no longer able to generate this magnetic field, and then the solar wind started pounding the surface of Mars. That's a scenario that a lot of people believe.
The loss of atmosphere stripped the Martian surface of warmth and pressure. And since water needs both warmth and pressure to remain in liquid form, water is no longer stable on the Martian surface.
put a pan of water out on Mars, it's going to evaporate very fast and try to freeze at the same time. One or the other will win out, but you won't have a nice liquid pan of water.
That's not to say, however, that there is no water on the planet at all. While liquid water is no longer stable on Mars, frozen water, ice, is a different story. And evidence suggests that still today, tons of water ice might lie just below the Martian polar caps. Locked within that ice might just be the holy grail of space exploration. They are visible through simple telescopes on Earth. And they are unquestionably the first planetary features noticeable during an approach to Mars through space. The Martian polar caps, mysterious snowy white ice swirls sheathing the top and bottom of the red planet.
It's actually what we call dry ice, frozen carbon dioxide. The atmosphere is very thin and it's nearly all carbon dioxide. So when it gets very cold, what condenses out is carbon dioxide snow, carbon dioxide ice.
But while the white caps are certainly a colorful planetary feature, it's not the frozen concentrations of CO2 themselves that are of most interest to scientists. It's what's thought to be hidden beneath the polar caps that could have massive significance. Lurking just below the topsoil may be millions of tons of frozen water. Water ice, hidden from view, appears to radiate out hundreds of miles in all directions from the poles. And leading scientists think it could be the residue of once vast oceans.
Likely the water is now frozen in a kind of permafrost beneath the surface. But maybe there are pressures and temperatures in various areas of Mars that have liquefied the ice and created perhaps aquifers.
We can see craters, an impact has happened. Asteroid has hit Mars, blown out a lot of stuff. It doesn't blow out dry powder like on the moon and make rays and rubble. It throws out kind of a muddy slurry of stuff. So the conclusion is that you're actually impacting into ice like northern Canada, permafrost layers, tundra kind of stuff.
Orbiting spacecraft have picked up strong indicators for the existence of water ice at the Martian poles. Remote measurements of soil composition have detected high levels of hydrogen. Water, of